Question 14a, Part 1. Show that 4n cubed plus 18n squared plus 23n plus 9 can be written as n plus 1 multiplied by 4n squared plus 14n plus 9. Expanding n plus 1 multiplied by 4n squared plus 14n plus 9, we get 4n cubed plus 14n squared plus 9n plus 4n squared plus 14n plus 9. Collecting the like terms, that equals 4n cubed plus 18n squared plus 23n plus 9. Hence, 4n cubed plus 18n squared plus 23n plus 9 can be written as n plus 1 multiplied by 4n squared plus 14n plus 9. Part 2. Using the result in Part 1, or otherwise, prove by mathematical induction that, for n greater than or equal to 1, 1 times 3 plus 3 times 5 plus 5 times 7 plus plus 2n minus 1 multiplied by 2n plus 1 is equal to 1/3 n multiplied by 4n squared plus 6n minus 1. The first step is to show the statement is true for some value of n. And in this case, the smallest value of n that we can test is n equals 1. When n equals 1, the left-hand side of the statement is equal to 1 times 3, which equals 3. And the right-hand side of the statement is equal to 1/3 times 1 times, in brackets, 4 times 1 squared plus 6 times 1 minus 1, and that evaluates to 3. Left-hand side equals right-hand side, hence the statement is true for n equals 1. Next, we assume the statement is true for n equals k. In other words, 1 times 3 plus 3 times 5 plus 5 times 7 plus plus 2k minus 1 times 2k plus 1 is equal to 1/3 k multiplied by 4k squared plus 6k minus 1. Next, we show the statement is true for n equals k plus 1. Now, from the left-hand side of the assumption, left-hand side equals 1 times 3 plus 3 times 5 plus 5 times 7 plus plus 2k minus 1 multiplied by 2k plus 1 plus the next term along, which is 2k plus 1 multiplied by 2k plus 3. And we obtain that by replacing k with k plus 1, so putting that in brackets, then expanding that, you get 2k plus 2 minus 1, and that's where we get the 2k plus 1 from. Now, from the assumption, we can replace this part of the series, so from here all the way to here, we can replace it with 1/3 k multiplied by 4k squared plus 6k minus 1. So in other words, this left-hand side of the assumption can be replaced with the right-hand side here. So the left-hand side equals 1/3 k multiplied by 4k squared plus 6k minus 1, plus the next term along, which is 2k plus 1 times 2k plus 3. I've just made a note here from the assumption. Now, expanding the brackets here and multiplying through by k, so just leaving the 1/3 outside the brackets, that's equal to 1/3 outside of 4k cubed plus 6k squared minus k plus 4k squared plus 8k plus 3. Now, factorising out 1/3 from these three terms, left-hand side equals 1/3 multiplied by 4k cubed plus 6k squared minus k plus 1/3 outside of 12k squared plus 24k plus 9. We now have a common factor, which means factorising this expression by taking out 1/3, left-hand side equals 1/3 outside of 4k cubed plus 18k squared plus 23k plus 9, so it's combining the like terms. And that equals 1/3 outside of k plus 1 multiplied by 4k squared plus 14k plus 9, and that's from part 1. And that equals 1/3 n outside of 4 outside of n minus 1 squared plus 14 outside of n minus 1 plus 9. Since n equals k plus 1, so we're replacing the k with n, and that equals 1/3 n outside of 4n squared minus 8n plus 4 plus 14n minus 14 plus 9. So it's expanding this bracket here and this bracket there. And collecting the like terms, that equals 1/3 n outside of 4n squared plus 6n minus 1. And that equals the right-hand side of the original statement. Therefore, by the principle of mathematical induction, the statement is true for all integers n greater than or equal to 1.